In this TCP/IP basics course, we're going to talk about the TCP portion as well as UDP, and we talk about those things as ports. TCP and UDP ports, they are like doorways, and there are 65,535 of each of them. So when we talk about hackers getting in through an open door, well, as you can see, there's over 130,000 of these ways for hackers to get in. So we need to lock down these ports, also known as doors, so that way we can keep our network safe. Both TCP and UDP, because of the number that you see there, are 16 bits or 2 to the 16th power. Now, does that mean anything? No, it's just what the scientists, when they created TCP and UDP, just what they decided it was going to be. They didn't believe they would ever need any more than these 65,000 plus ports. At this point, it still seems to be a usable amount of ports, but in the future, this may change to another version because we may need more, similar to what happened to the IP addressing side, where the IP version 4, we only had 4 billion addresses, which we used up a long time ago, and we're starting to move to IP version 6, which has a lot more IP addresses. Now, the first 1,024 of both TCP and UDP ports are what's called well-known ports. And what that means is they were registered ports. So these various different companies and organizations, they registered these ports. Now, strangely enough, some of these companies that registered these ports are no longer in business, yet they're still registered to them. And there's no real great way to get them off at this point, but that's okay. Ports like port 80 for web traffic or port 25 for email traffic, those were not registered by any particular company. They were just decided upon that everyone would use those ports for that particular type of traffic. So let's talk about TCP, Transmission Control Protocol. So this is one of the two types of protocols that sits on top of IP. And actually, there's a lot more than just these two. They're just not as well known as TCP and UDP. But we're just going to talk about these two because these are the most popular ones. So this is what TCP stands for, Transmission Control Protocol, and it is a connection-oriented protocol. It sits on top of IP. So if you look at the OSI model, you'll see that at the transport layer, that's where TCP and UDP sit. And they literally sit on top of the IP layer, which is layer 3. So TCP sits at layer 4 at the transport layer, and IP sits at layer 3 at the network layer. So what does connection-oriented mean? Well, it means end-to-end connectivity is assured. It's going to make sure a packet gets there, and it's going to make sure that that particular device where it sent it acknowledges that it was sent and received in good standing. So here's some examples of TCP ports that we use every day. So if you go to a web page, you're using port 80 or port 443 for secure web pages. SSH, which is Secure Telnet, is port 22, so it's an encrypted type of telnet. You can see telnet itself is port 23 for people who still use that. And FTP for File Transfer Protocol is port 21. So all of these have end-to-end connectivity assured. So when a packet gets sent using TCP over IP, if there's an error detected, it's going to resend that packet. And that's good news because that way you know when you send data such as email from one location to another that it will get resent if necessary. It is slower than UDP, but it is more reliable because you know that it's going to get resent if there's any errors. There's also more overhead, so it's going to use more resources. Now, in a small network, you're not going to really notice that, but in a larger network, you might need to add additional network cards and have them trunked together to sort of balance the load so that way TCP won't slow down your network. Let's talk about UDP for a second. User Datagram Protocol. That's what that stands for. And it is connectionless. So it doesn't do what TCP does. It doesn't resend if there's any kind of error. It's connectionless. It just sends out the data and hopes that it shows up. And it sits on top of IP at the transport layer, whereas IP sits at the network layer, which is layer 3. So there's no assurance of connectivity. And this is pretty common for people who want to send data very quickly but don't really absolutely need to have every packet show up healthy. So there are different types of programs that are fine with not all the data packets getting there. So DNS for one. Well, if DNS doesn't get through the first time, you can always do a second check, and then the second time you can get through. There's also a TCP version of DNS, but by default, we use the UDP version because it's faster. Streaming media applications such as movies. Hey, it's okay if you have a blip in a movie when you're streaming a movie that's several gigabytes in size. Because it's just not that important. The majority of the movie is going to get there. We want speed. We want that movie to show up quickly. Online multiplayer games, another thing. So if you drop a few frames here and there, not that big a deal. It's fine. Voice over IP. Again, if you hear a little crackle in the voice when you talk to somebody on an IP line, it's because a packet got dropped, and that's using UDP. And trivial file transfer protocol. So instead of FTP like we talked about, we have TFTP, which sends very tiny programs across the internet. So these are all examples of UDP. Doesn't resend if errors. If there's any kind of error, sorry, it doesn't resend. Software may correct this, however. So there are some new software programs that are filling in the gap for what TCP does, where if there's an error in the packets, it will go and correct it and resend it. So the software will detect whether or not the packet didn't get there rather than UDP itself, because UDP, as we know, doesn't care. It is faster, but it is less reliable unless, once again, you have software that can correct some of these problems. And it uses lower overhead, so you tend to not need to bunch together a bunch of network cards with UDP because you don't have the same amount of overhead. TCP and UDP sit on top of IP, as mentioned earlier, and they are excellent protocols that can be used to send data either reliably or quickly on an IP network.